Hello everyone. This work was carried out at Universidad Michoacana de San Nicolás Hidalgo and the title was Synthesis of Cupric Oxide Nanoribbons by the Chemical Reduction Method. This work was developed as simple time-dependent method to synthesize cupric oxide nanoribbons. For this, the concentration ratio of the surfactant, in this case PVP, to the precursor salt, in this case cuprum chloride, and the reaction times were varied. The cupric oxide nanoribbons were characterized out using the scanning electron microscopy technique, which confirmed the formation of cupric oxide nanoribbons after 3 weeks of aging, with dimensions around to the 60 nanometers for 2 micrometers. In addition, other analysis was completed like X-ray diffraction and transmission electron microscopy that confirms the monoclinic structure of the nanoribbons. This result shows the influence of the PVP concentration ratio on the morphology of nanostructures. Therefore, it can be concluded that long amounts of PVP increase the oxidation of the particles, which facilitates the formation of cupric oxide nanoribbons. Figure 1 shows a scheme of the synthesis of nanoribbons. The nanostructures were synthesized by a chemical reduction method using copper chloride as precursor salt and sodium borohydride as a reduction agent, and polyvinyl pyrrolidone (PVP) as a surfactant agent. The nanoribbons are promoted in an aqueous solution by an aging process and bathed PVP and mouse. The synthesized samples were characterized by different techniques that corroborated the reported material. In Figure 2 shows micrographs obtained by scanning electron microscopy, showing images at different magnifications, in which a simple number of nanoribbons with homogeneous sizes and shapes can be seen. The chemical mapping analysis in Figure 3 indicates the X-ray distribution of the element copper and oxygen corresponding to cuprous oxide. This statement was corroborated by X-ray diffraction analysis. The results are shown in Figure 4. The diffraction pattern indexes the monoclinic structure of the cupric oxide. Continuing with Figure 5 shows the results obtained by transmission electron microscopy. The bright field images show the tips or the nanowires with sizes smaller than 3 nanometers, which makes it a material with potential for application. Also shown is a high resolution image indicating the interplanar distance of the 111 or 002 planes. A micrograph is also presented showing the formation processes of the nanoribbons by varying the precursor salt concentration and the formation of stable octahedra attributed to the amount of PVP used. In conclusion, the work was developed as simple and time-dependent method to synthesize cupric oxide nanoribbons. SEM and EDS techniques confirm the morphology and chemical composition of the cupric oxide ribbon-like particles. At the same time, X-ray diffraction and transmission electron microscopy techniques confirm the monoclinic structure of cupric oxide nanoribbons, mainly appear with a 3-week aging reaction after mixing cuprum chloride, sodium borohydride, and PBP to the concentration of 17 millimolar of the precursor salt. A hedgehog form develops without using PBP. At the same time, the ribbon-shaped nanostructures grow in the presence of PBP and same nanosheet-like nanostructures with lengths less than 1 micrometer and thicknesses of 100 nanometers are formed. The presence of PBP also influences the morphology obtained. For example, adding less quantity at a salt concentration of 15 millimolar forms spherical particles that oxidized, forming cupric and cuprous outside nanoribbons. On the other hand, by adding less amount of PVP, 3 was less oxidation forming octahedral particles and a much smaller number of nanoribbons. So, thank you for watching.